Hi, good morning and welcome to this class. In today's tutorial video, we shall be solving more problems on Kirchhoff's law. So in these diagrams, we have I1, I2, and I3 to find the values. These are currents. The current for I1 flowing through this resistor, 10 ohm. The current I3 following into this. This is here is 8 volts, so you have 8 volts. 8 volts. So you find the current I2 flowing through this. So we are expected to find I1, I2, and I3. The same thing applies here. You have 7 ohm resistor here. You have for this you have, so this is 6 volts, this is 8 volts, and we're expected to find I1, the current I1 passing through this side, current I3 passing through this side, and current I2 passing through this side. This is 5 ohm and this is 7 ohm resistor. In this problem number 3, we're expected to find just I2, that is the current flowing through this resistor, 1 ohm. So if you have not watched our previous video on Kirchhoff law that served as the introductory video to this, you can check our playlist. So in this problem, we shall be making use of the Kirchhoff's current law and Kirchhoff's voltage law. Let's get started. For this problem, for us to solve it, we write the Kirchhoff's current law and Kirchhoff's voltage law. So what the Kirchhoff current law states? It states that the sum of the currents in a circuit should equal 0, or the sum of the currents entering a junction equal the sum that leaves the junction. For Kirchhoff's voltage law, it states that the sum of the potential, the EMF in a circuit, the sum of the EMF in a circuit and the potential drop across the circuit elements, across the resistors, that it should equal what? 0. We shall be making use of these two laws to resolve this problem, to find the value of I1, I2, and what? I3. And for us to do this, we have stated some sign conventions. So for you to solve problem involving Kirchhoff's law, you have to identify usually a node, a junction. Then you identify a loop and you choose the direction you are going to follow. You either follow a clockwise direction or anti-clockwise direction, usually from the junction. If you are moving in the direction of the current and you are passing through a resistor, you have a voltage drop. But if you are moving and your motion is against the direction of the current, so you have a potential lift. For instance, now, if you look at this, we are moving in line with the current if we choose to go clockwise. So I can decide to go clockwise. This is clockwise direction, clockwise. So what the direction you go for one of the loops, you go for the other. This is another clockwise motion. But before you identify this, let us label this A, B, C, and D. Then let us use a different color so that it becomes very clear. This is A, B, C, and D. A loop is a closed path in a circuit. If you notice, A, C, and D, they are closed, so this is a loop. Notice again, A, C, and B are closed. It's a loop. So in this problem, we have two loops, A, C, and D, and A, C, and B. In the other example we solved in our last video, we solved only one that has a problem that has only one loop. For instance, now, if there is no current that flows through this side, this and this becomes a series connection. And I have said again, we make use of Kirchhoff's law when the circuit becomes complicated. For instance, you see that there are more than one source of EMF. You have 8 volts, you have 6 volts, you have 12 volts. So for you to find values of I1, I2, and I3, it becomes difficult if you don't know the Kirchhoff's law. But the Kirchhoff's law will make it easy for us to resolve and find the values of I1, I2, and I3. So if you have identified a loop which I have labeled A, C, and D, and A, C, and B, then you choose the direction you are going to follow. You either follow a clockwise direction or anti-clockwise direction, and what you do here, you do there, you do here too. So let us follow a clockwise direction. And again, in our last video, I said that if, for instance, we are moving in the direction of the current, this is clockwise motion, and this is the flow of the current through this resistor, 16 ohm. You notice here that we are going to have a voltage drop because we are moving in line with the current. That is for resistors. Then for sources of EMF, when we are moving from the positive side of the cell to the negative side of the cell, we are moving downhill and the EMF here becomes negative, so we have minus 12. But if we are moving from the negative side of the cell to the positive side, so we are moving uphill, the EMF here is positive. So we shall be making use of these sign conventions to find the values of I1, I2, and I3. Let's get started. First of all, I will identify a junction. A junction is a place where 3 or more wires meet. So this is just like wires in a circuit. Resistor, you have wire, you have wire, you have a cell, you have wire, you have, this is a junction, you have another cell, just in that order. So let us identify this and use this as our junction. So the junction A. So let us start our movement. So we'll start moving from this side, and we have met a resistor, and our motion is in line with the flow of current. So we are going to have a voltage drop here. From Ohm's law, V equals IR. And the resistance we have there is 16 ohm. So we have minus 16. The current flowing through this side is I2. We have I2. So I'll have minus 16 I2. We keep moving. Then we meet a source of EMF. Look at how we are moving. We took A, C, and D as the first loop, and we want to, through taking this clockwise movement, we want to find the value of I2 and I3. All right, so meeting this source of EMF, we are moving from positive side of the cell to the negative. Positive is the longer side. So as I have said, you are moving downhill. So the EMF here becomes negative. So I have minus 12. You see, I'm not writing I2 again because this is just source of EMF. Here, we made use of Ohm's law to find the potential drop. So you have minus 12. We keep on moving. This is I3. I3 flowing through this side. And we have we are moving from the negative side of the cell to the positive side of the cell, we are moving uphill, we have plus 8. Everything should equal what? 0. So if this is a path, closed path in a circuit, the sum of all the currents should equal 0. Then let's take the other loop. Let's move from this side, the same clockwise direction as we moved here. So starting from here, we start moving. This is the positive side of the cell and this is the negative side. So we are moving downhill. The EMF here becomes negative. We keep on moving. We meet this one. We are moving uphill, negative to positive. So the EMF becomes positive. We keep on moving. We are moving in the direction of the current. So we are going to have a voltage drop here. So you have minus 10. The current flowing through this side is I1. So we equate everything to what? 0. Now look at this. We would have solved this problem simultaneously, but this type is trivial. What we are just going to do, let's call this equation 1, call this equation 2. For equation 1, we have minus 16I2. You have minus 12 plus 8. Minus 12 plus 8, you have minus 4. Minus 4, everything should equal 0. So that minus 16I2 equals 4. If I make I2 subject to the formula, I have 4 upon minus 16, and you have minus 0.25 ampere. So our I2 now becomes I2 from here. You have minus 0.25 ampere. This is just showing the direction of the current, the true direction of the current. Our interest is in a magnitude. So we can find I1 following the same method. Minus 8 plus 6 is minus 2. You have minus 10. I1 equals 0. We are collecting like terms from equation 2. You have minus 2 equals 10I1. 10I1, because this will cross. So making I1 subject to formula from here, you have I1 equals minus 2 upon 10, and this is minus 0.2 ampere. Again, we're interested in the magnitude. This is just to show you the direction. So you have negative 0.2 ampere. So I found the value of I1 and I2. We found the value of I1 from this, making I1 subject to the formula. We found the value of I2 from this, making I2 from subject of the formula. You have I2 equals minus 0.25 ampere. Now, let us look at other examples. There are some problems that you are required to solve it simultaneously for you to find the values of I1, I2, and I3. If you notice here now, we have just gotten the values of I1 and I2. How can we find the value of I3? To find the value of I3, we make use of the Kirchhoff's current law. This is a junction. You notice I1 is entering the junction. I3 is entering the junction, and I2 is leaving this junction. So this is what helps us find the application of the Kirchhoff's current law in this circuit. So you have the sum of the currents entering the junction, which is I1 plus I2, that it should equal the sum that leaves the junction, which is what? I2. So I1 enters and I3 enters. So the sum of the currents entering is I1 plus I3. This is the junction, and I2 leaves. So since we have known the value of I1 and I2, we can make I3 subject of the formula, so that you have I2 minus I1. And I2, we got it as minus 0.25. then you have minus, open bracket, I1 is minus 0.2. So once you do this math, you have minus 0.05 ampere. The negative sign is just showing the true direction of the current, and our interest is in the magnitude. You should know that from these negative signs we are getting, the negative sign in the direction of the current indicates that the true directions of the current are opposite to the direction assumed in this problem. However, the magnitudes are correct. So our interest is in a magnitude. So we've been able to find I1, I2, and I3. We shall be making use of these laws, Kirchhoff's current law and Kirchhoff's voltage law, to solve the rest examples. For this problem, we can have two loops too. You have A, C, you have A, B, C, D is a loop. You have A, B, F, E is a loop. So we are expected to find the values of I1, I2, and what? I3. And if you look at this problem, you notice that I1, I3, and I2 all are entering this junction. So we can make use of Kirchhoff's current law to resolve this. That the sum of the currents in the circuit, should equal 0. So have it that I1 plus I2 plus I3, that everything should equal what? 0. So we can now find our direction of movement. We can decide to go anti-clockwise in this case, that is starting from this junction. So the junction is usually our area of consideration. So we have anti-clockwise motion. We can go anti-clockwise again here. So going anti-clockwise, for instance, for this, we are moving down here from positive to negative. So you have minus 8. Then you keep on moving. You notice that our motion is opposite in direction to the flow of the current. So we are going to have a potential lift here. So from Ohm's law, you have plus 5, and the current is I2. We are still moving again. Moving from positive to negative, you have minus 4, and everything should equal 0. We have reached this junction. So we start our movement again from this junction and take another anti-clockwise motion. So moving from this, reaching here, we have positive EMF, because this is negative to positive. So you have 4. Then you keep on going. If you notice that once you come here, your movement is in the direction of the current, and the current that flows through this is I1. So from Ohm's law, you have minus 7 I1. So you keep on moving, meet this source of EMF. You are moving from negative to positive. You have plus 6. So you have this. You have completed the loop. You can call this equation 1, call this equation 2. So from equation 1, we can have that. 5I2 minus 12 equals 0. So making I2 subject to the formula, you have 12 upon 5, and this is 2.4 ampere. So similarly, for equation 2, this is plus 4. Plus 4 plus 6 is plus 10. So doing the same thing again here, you have minus 7 I1 plus 10, everything should equal 0. So that if you make I1 subject of the formula, it will be, this one will cross, so it should be 10 upon 7, and you have 1.45 ampere. So you have for I2, 2.4 ampere. You have for I3. Have we found I3? No. We have for I1 1.45 ampere. And we are yet to find I3 because the question says find I1, I2, and I3. So we shall make use of this, that the sum of the currents in the circuit should equal 0. So you have that I1 plus I2 plus I3, everything should equal what? 0. And if you notice, our interest is in finding I3. Have I3 equals, if this one crosses, it will be minus I1. This one crossing is minus I2. You have minus, the value of I1 we have gotten is 2. Okay, I1 is 1.45 minus I2 is 2.4. So minus 1.45 minus 2.4 is approximately minus 3.8 ampere. Again, the minus sign tells us that I3 is opposite in direction to that shown in the figure. So for this figure now, I3. So the minus sign, as we have gotten in this answer, it tells us that I3 is opposite in the direction to the one shown. So our interest is only usually on the magnitude. So I3 is 3.8 ampere. So in these two problems now, we have used the Kirchhoff's current law and Kirchhoff's voltage law to find the values of I1, I2, and I3. Now for the third problem, this third problem, you shall make use of Kirchhoff's current and voltage law to find the value of I2. That is the value of the current that flows through this resistor 1 ohm. So I will leave you to solve this and put the answer in the comment section. If you have enjoyed this section, if you have enjoyed this lesson, you can subscribe for more updates and click the notification bell. And you can share it with your friends and invite your learning colleagues. In this channel, we prepare you for your exams. We teach, we have tutorial classes for undergraduate students and high-level school students. So if you have enjoyed this video, you can give it a thumbs up, invite your learning colleagues, and have a wonderful day ahead. So in this problem, there are some problems that will require solving simultaneously to find the value of I1, I2, or I3. We shall see that in the next video. But for the meantime, solve this and find the value of I2. That is, the value of the current that flows through this resistor. In our next video, I am going to solve this again and you will see how it is gotten. But for the meantime, solve it and give us the answer in the comment section. Have a wonderful day ahead. Good morning.